All right, is this working? It is, perfect. All right, my name is Olivia Vernon. This is my first project for visual programming, and I decided to go with a game of Hangman. Here we have our main form. We'll go over all of this in just a moment. And here we have our base design when it loads. For the player to see. What I'm going to do is I'm going to give a quick rundown on how the program works by showing you as it goes, and then we'll go over the code in just a moment. So, Hangman, it operates about as one would think a Hangman game should operate. You're given a word here that is hidden. It is 4 letters. We type our guess into this box and hit the guess button. If it's wrong, it's going to add it to our wrong guesses list and update our photo to show that we only have so many chances left. If we try to guess the same letter again, we are warned that we have already guessed this letter and we cannot use it again. Oh, we have a correct letter now. So because it was correct, our progress towards doom did not advance, our wrong guesses list did not update, and we got 100 points for that. Nice. See, every time we guess wrong, we're going to lose 50 points, though we will not go into the negatives. Whoop, already used that letter. Oh no, game over, we couldn't guess the word. We are given our high score, which in this case was 0 as we ran out of points. And our game restarts. Now, let's say we've got some progress in our game and we decide we want to reset our game. We have a reset button. Because this is a dialogue warning, you're about to reset your game. And that resets our whole game, including our score. If we want a hint, we just can't quite guess what that word is and we're getting nervous, we can hit our hint button and that gives us a random letter. In this case, we're going to get dance. Now that the word is complete, we just need to hit our guess button one more time. And we are told, congratulations, you figured out the word. Would you like to continue? If we say no here, it will close our game and tell us our high score. If we were to say yes, it would restart the whole game, which we can show. Let me see if I can get this word correct. Possibly. I will not be getting this word correctly, it seems. Oh, wait, I know this one. This gives me a chance to show, because we got those 2 letters filled out, it gave us 200 points on our scoreboard, plus 100 for the I. Though we did lose some points thanks to our wrong guesses. And right before we can make that last mistake, we have gotten our word silly. Congratulations, we have figured out the word. Now we're going to try yes to continue. Our score stays the same and carries on with us. Now if the user attempts to add more than 1 letter, we're going to get a warning, 1 letter at a time. And should they try to guess that anyway, we were told that guess is too long, your guess must be a single character. And for convenience's sake, our box is emptied. If we try to guess any symbols, let's say an exclamation mark, invalid input, your guess must be a letter. Should they try to enter nothing at all, invalid input found, try another guess. And so we can see that almost anything a user could put in will be accounted for to some degree, even numbers. So what's going on behind the scenes here? We can now see that over here. We have our word bank of all of our words to guess. And you'll notice the first thing that happens after the initializing component is we call upon a function called reset game. And if I go down to reset game is going to give us that first image. It's going to empty our wrong guess label. It's going to empty our guess input, set our correct to 0, clear out our guessed letters, and check to see if the game is complete, which in this case, it is not, so it will not be resetting our score. Not that it would need to. But you may see here, it's going to call upon getWord. GetWord is our function in order to go retrieve a word from our word bank and set it as our answer. For this, we use a random function, random.next, between the first word and the length of our word bank. Setting it to the length of the word bank allows us to make a word bank that is larger or smaller and still have this function work as needed. It'll set all of our blanks, clear out our hidden word in case there's anything in there. And then for as long as that answer is, we add our dashes. We then turn this list of characters into a string, combine them all together, replace our commas so it doesn't look ugly, and then set that string to our hidden word, or word hidden. That's going to give us a new word pretty much every time we reset. Here is our check if guess is longer than 1 character, which is going to make that length warning label visible whenever it is too long. Here is our button reset with our dialog box. The dialog box is there to make sure the player really did intend to reset their whole game. Should they click OK, it calls upon that reset game function. Yeah. Should the player click on the hint button, we're going to call upon that hint method, which we'll go over in just a moment. And we're going to make sure that the word has not been completely revealed. In order for this to work, we have to use a Boolean all-revealed value. And here I have it set to true, as within this statement, If all has not been revealed, we'll change it to false. But in case everything's been revealed, it's set up here. You'll notice here, we use another temporary list of characters in order to use our hint function. Our hint function, all the way down here, is going to get a random number between 0 and the length of our hidden word or hidden dot count. And if that letter has not been revealed, we will reveal it. If that letter has been revealed, however, already, then we will recursively call the function and try again until it finds a space that has not been revealed. Where is it? Button hint. There we are. Now, to make sure that function doesn't call itself recursively over and over and over because all the letters have been revealed already, this is why we have all revealed. So if everything has been revealed, we'll simply display a message box saying, "You are out of hints. Good luck." Now for the big part. The most functions we're going to use for our program whenever we hit that button guess. Button guess is going to check to make sure our word is complete. If our word is not complete, if there are blanks present, it will set it to false and break out of that statement. If we complete our word, we're going to set our new high score and reach our first game over type, the good one that says, "Yay, we solved the riddle, we solved the word." Would you like to continue? If they decide to continue, we reset our game, get our new word. If they say no, we're going to close our application and display their high score. That's if it's complete. If our word is not complete, then we will set it to true to try on this next cycle. Because we're going to go up here, and if it's checking out, if it checks it out and it goes, "Yep, it is false," then it's going to skip this anyway. But in order for it to detect, "Hey, we need to go check," we need to set it true within our else. I know, it's a little wonky, but it works. Here, we're going to attempt to parse our input into characters, into guess. And this is where an exception is most likely to be thrown. This is where it checks for multiple characters, for symbols, for anything that isn't a single alphabetical character. And we're going to make sure it is a character, checking is letter, result. If it's a result, then we can go ahead and process it further, such as if our guess is correct, if our answer contains our guessed letter, and our guessed letter is not part of our guessed list, aka the words that or the letters that we have already guessed at, then we can try to reveal the letter in the hidden word. And when it's in there, we add 100 to the score. This helps account for letters that appear multiple times within a word as well. We're going to create our temporary string, replace any spaces, trim it down in case there were any spaces missed, set it, and set our score to string, keeping all these zeros in place. When our guess is incorrect, so our guess is not contained within our answer, and it's not part of our guessed list, we're going to lower our score without going into the negatives. just to make things easier on the player. We're also going to add that guest thing to our guest string. And then we're going to increment our wrong guest text. That way it looks pretty and the letters don't go way off the screen. That would not be pretty. Most importantly, our incorrect counter increments. Then goes into our switch statement to determine which image to display. All the images I made in Microsoft Paint, and I saved over each and every step. That way, you get multiple chances to guess until you hit your game over, the bad one. In this case, you have guessed and gotten it incorrect multiple times. So we set our new high score, if there is one, reset our score. We're told we couldn't guess the word your high score is, and our game is reset. And so we break away from our switch. Now we reach the point where if a letter was already guessed, we're given that message box and our string is emptied. The text box guess input is emptied. If our guess wasn't a letter, we're warned as much. And should we pass through all of this and our letter was good and it hasn't been added to the list, it has now been added to the list here. Here's our catch to catch everything else if it wasn't an alphabetical letter. If the guess is too long, we're warned. If we're getting an invalid input, you're warned. All right, I believe we've been over get word. I believe we've been over reset game. And we've been over this. All right, and that's my program. If you have any questions, feel free to email me and I'll get back to you as soon as possible.